30. And then you divide both sides by minus 30. So it may or may not be the case that A is a nice value. So in this case, it's 2 over minus 15. Bring the negative up, negative 2 over 15 like that. And then that goes back into that line right there for A. So your P of X equals negative 2 over 15, X minus 2, X plus 9 like that. Any questions or thoughts on that?
No.
Okay. We can do another one like it. Number 3 on that piece of paper you sent over. It's very much the same style, but then there's other things you could be asked to do. So just keep that in mind here.
I can do number 3.
What's that?
Can we do number 3?
Yes, we can do number 3 here. So it's if you were to make just a rough sketch, there's 3, 0, there's 7, 0, and then minus 3, minus 5. We would presume it would do something like that. The graph would do something like that. And I use this P of X notation. You can use Y, you can use F of X. I mean, it really doesn't matter. But you do have to get the two X-intercepts in there first. So that's X minus 3, X minus 7. And then why don't you try solving for A?
A equals 12.
12, okay. That seems, it should be a fraction because we've got minus 3, minus 3, minus 3, minus 7. Is this what you have for?
Yeah. And I got
Okay.
negative 5 equals 60A.
Okay. Now that's good. But you're dividing. So it's 5 divided by 60, which is a fraction. You're right. So like 60 divided by 5 is 12, but 5 divided by 60 is 1 over 12.
Oh, okay.
So A is minus 1 over 12 in this case. And then that goes back into this line here. Y equals minus 1 over 12, X minus 3, X minus 7. Okay, any questions on that?
No.
Okay, so there, like, I could give you another problem like this. We could do like number 4 on that sheet, which is related to this problem. Like, what else would you like us to do today? There's of course some other standard forms that I'm seeing that you might need to know.
Um, can we do number 4 to number 3?
Yes. All right. So this is a pretty tough problem because you're basically in the completely the wrong form here. Um, the vertex form is a x minus h squared plus k. The only thing that it shares from the form we just wrote, the factored form, is the a. The a is the minus 1 over 12. The a is shared, but we don't know the vertex of this. Okay, so there's a couple of ways that we can go. One is we do need to FOIL or expand this x minus 3 times x minus 7. So we can do that. We can do that down here. Y equals minus 1 over 12. And then we're going to FOIL. So that's x squared minus 7x minus 3x plus 21, like that. And so this becomes x squared minus 10x plus 21 with this minus 1 over 12. Is that okay up to this point?
Yes.
Okay. So the way to proceed from here, unfortunately, is we do have to multiply in, and then you're supposed to complete the square, but you can actually kind of do it without completing the square. You can use formulas. Um, you can do this minus b over 2a stuff. What were you guys doing in class? Completing the square or
Um, I'm actually not sure because I missed the day that we went over this, and the paper that we're doing it on is our note. So I'm
okay.
not sure what she
Well,
had.
the thing here that's um, it's like I don't know which way to go. Because I did see some completing the square on your other page.
That sounds more familiar. To complete your square for these ones.
So, um, yeah, how to do this. So, like this is not the best problem to start with completing the square, but you start by taking half of this number right here, and I'll just sort of talk through this one. Um, if you were to expand this, okay, and this is kind of off to the side here, you would get, if you were to FOIL this, you would get x squared minus 10x plus 25. Do you see that you would have more than 21? You would have
4 more.
25 instead of 21.
Yes.
So if you subtract 4, you would get back to the 21. Do you agree with that?
Yes.
And so this thing inside the box, these are now equivalent. This x squared minus 10x plus 21 is the same as this. Do you agree with that?
Yes.
Okay, so then you can bring this minus 1 over 12 down, and then you can distribute it into both. So it's minus 1 over 12 x minus 5 squared plus 4 over 12, which is really 1/3. And now this is finally in vertex form.
Okay.
All right, now normally they ask you for the vertex. They don't seem to be doing that here, but that's the whole point of putting it into vertex form, is that you can get the vertex. Now, if you didn't understand that, we should maybe go and do a completing the square or talk about that. Or we can just completely shift to the other types of equations, which is 5 and 6 in vertex form and then standard form.
Can we try the different equations?
Like number 5, for
Yeah.
example.
Number
Yeah.
5.
Yeah. So just like the thing that maybe isn't clear at this point is that there are three equations of a quadratic. There's standard form, which is ax squared plus bx plus c. There's vertex form, which we just did, x minus h squared plus k. And then there's factored form, which is a x minus p, x minus q. And the only thing that's the same about them is the a value. All right, so now in question five, we have to end in standard form, but we may not start there. So whenever they give you the vertex, you're going to start with vertex form. So the -411 is the vertex. That's the h and the k value. Right, so we're going to put those values in x minus a minus 4 plus 11. Is that okay?
Yes.
So you do want to simplify the signs, and then you're going to use the second point. So you kind of asked me that earlier, like, yes, you have to use the other point. You have to use that as the vertex. This is the other point to find a. So you're going to use those values in for x and y and solve for a. So 15 equals a minus 6 plus 4 squared plus 11. To do this correctly, you do want to get rid of the minus, the addition by 11 first. And then -2 squared becomes 4. So 4 equals 4a, divide by 4, divide by 4. So you end up getting a equals 1, which is pretty nice. We actually didn't have any nice ones in the previous ones. All right, so your final answer is x plus 4 squared plus 11, but that's if they want it in vertex form, which they don't. So we'll get to how to turn it into standard form. But that's our answer. So to go from vertex to standard form, you have to FOIL and then combine like terms. Okay, so we had y equals x plus 4 squared plus 11. So you first have to FOIL the x plus 4 times the x plus 4 plus 11. All right, so could you FOIL that for us, please?
Is it x squared plus 4x squared plus 16?
I get x squared plus, I think, I don't know exactly what I heard there. It should be x squared plus 4x plus 16. And then the outer and the inner combine. If you got something different, maybe take a look or ask me some questions, but the first term is the only squared, and then the outside is just 4x, the inside is 4x. They're just squeezed together. And then you combine like terms here, so you get 8x plus 27, and this is your standard form. Is that okay?
Yes.
Okay. So number 6 is really similar. So just to recap what we did here for number 5, we first wrote vertex form. So if you don't have that written down, you want to get that down. Paper. You put the vertex in for h and k, then use the other point to find a. So I'd like you to start there with number 6. Start by writing vertex form, substitute in for h and k, and then use that other point to find the value of a. And I'm here, of course, if there's any questions, but take a minute or two to see if you can work that out.
Okay, I got A equals um -2, and
Okay,
then
let me double check you here just as like that and just check your work here. That seems reasonable because the value is it ends up being yeah. So when you subtract 2, you get -8. -8 equals A times 2 squared, which is 4. So A is definitely -2. Very good. Like it. So now to go to standard form, you first have to FOIL this. So forget about the -2 on the outside, just FOIL x minus 1, x minus 1.
the x squared minus x plus 1.
So there's two minus x's, right? It's minus x and then minus x plus 1. The the -1x minus 1x. I mean, you're just squeezing those together, and then they combine to -2x. We should maybe do another FOIL problem after this so you can see that, because you will be doing that a bunch in this course. Now, the next thing here is that you have to multiply in that -2 to everything, each of these. So that becomes -2x squared plus 4x minus 2 plus 2. So the -2 and the +2, they cancel. And you end up getting -2x squared plus 4x. Any questions on that?
No.
Okay. Just looking this over. I don't know, it just doesn't quite look right, but that's not for me to just decide. So I think we should do just a couple of FOIL problems, maybe just one here. But could you try foiling x minus 3 times x minus 3?
The, x squared minus 3x plus 9.
Good. And then what happens when you combine those two terms? What does that become?
Is it just x?
It's minus 6x. They're they're both negative so that the sign stays the same, and then you add the numbers without the sign. We could do a quick review on that if needed, but it's as if they were both positive. If it was plus 3x, you would write 6x. But since they're both negative, you keep the sign, but you add the numbers without the sign.
Okay.
It's a complicated way of saying it. You probably remember how to do that, but it's okay. So we can do more quadratic stuff, but it kind of looked like your teacher's moving you into completing the square and then some polynomial stuff, higher degree polynomial.
Yes.
What would you like us to do next?
Um, can we do one of the division ones?
I didn't see any polynomial division. Let me look double check here. Maybe I miss. Oh yeah, there we go. Okay. So that's the Tuesday lesson. So we'll do some synthetic division there. Yep, that sounds good. Now this is different than polynomial division. It's preferred. Is that okay?
Yes.
All right. So the first thing to do is to figure out where this number, where x plus 3, this factor equals 0, and it's when x equals minus 3. That goes in this box over here on the left. And then you write the coefficients 2, 10, 14, and 6. If there was a subtraction, you'd keep the sign. So 2, 10, 14, and 6. You leave a little space. Now you always bring the first number down. Okay, and then you take that number 2 and multiply it by the number in the box. So that becomes negative 6. 10 minus 6 is positive 4. You take that 4 and multiply the number in the box, partial box, that's minus 12. You add, you're always adding vertically. I guess I should say it here, you're adding vertically. And then you take that 2 and multiply it by the minus 3, which is minus 6, and you get 0. Let me know when you get caught up to that point.
I've got it.
All right, so we're not done, but we've done the first part. So originally it's 2x cubed, 10x squared, 14x. So when you go when you divide it, it reduces the degree. So it now becomes 2x squared instead of x cubed plus 4x plus 2 like that. So the degree gets reduced each time it works out. And then they want you to factor completely. So the very first type of factoring you always try is what's called GCF. So there's a 2 that goes into everything. Hopefully that all looks familiar.
Yeah.
Do you remember how to factor something like this?
I don't.
So you're looking for two numbers that multiply to 1 but add positive 2. Multiply to 1, multiply to the last, but add to the middle number. And that's only the case here because there's a 1 in front of x squared.
Is it just x plus 1?
I didn't quite hear you. Sorry.
Just x plus 1 in the parentheses?
Yeah, x plus 1 and x plus 1. So that's just this part of it. You then pair it with the one that you started with all the way back in the beginning of the problem, which was x plus 3. And so this is the factored form of that original polynomial. So this is what your instructor is looking for. Right. Would you like us to do a few more synthetic division problems?
Yes, please.
Okay, so let me go look for some that work. That's the key here. There's some that don't work. And that's not all that useful. Want some that do work. All right, so here is one for you to try. So I'm just going to start by putting the number in the box. And then I want you to work out the rest of it here. I just want the numbers that go in the rest of the table.
Is it okay if there's leftover? Or is it
Yeah, so and that's why I had you do this one, because sometimes it doesn't work out. And you probably saw that here. What is the remainder?
I got 36, so I don't know, because I started off as you, and then I put a negative, or instead of -1, I put a +1, and so
Okay,
then
but
I put a negative
so that,
7.
yeah, that'll change it. But 27 minus 28 is -1. Okay. So just be careful with your signs there. And then -1 times -7 is 7. 3 plus 7 is 10. 10 times -7 is -70. So so here's what this means. If it's not 0, that means it's not a factor.
So like -7 wouldn't be a factor, basically.
So it doesn't always work, but I mean, I want to give you some that do work. It's just that we've got to just kind of learn our way through this a little bit. Um, so let me find one that does work here. I think I'm gonna just make one up because that'll be easier than these worksheets seem to be emphasizing other things. Okay, so let's say it's x plus 1 into x to the 5th minus 12x to the 4th plus 49x cubed minus 66x squared minus 32x plus 96. This one does work. Now, what number goes in the box?
-1.
Yeah, that's really important. So then what's the coefficient of x to the 5th?
Do you put a 1?
Yes. So it's 1, -12, 49, -66, -32, and +96. So you should get 0 at the end. So give this one a try, please.
Not sure.
Let's take a look here together. If you'd have 1 here, what did you write in this next position under the -12?
1.
So you're multiplying these, that should be -1. So 1 times -1 is -1, then you add these together to get -13.
Valid.
Right. And I don't know if your teacher allows you to use a calculator or not. I mean, I would certainly have one out for homework and stuff just to avoid, sign errors and stuff. Then you take this -13 times the -1 in the box. That's +13. So you add those together and get 62. 62 times the -1 is -62. We're up to -128, which it's starting to look bad. It's starting to be like, I don't know if this is going to work. -128 times -1 is 128, which gives you +96 when you add. You're always adding vertically. And then you multiply by -1 to get -96. So let's try one now with smaller numbers, with like another little wrinkle, things you might see in this class. So they might ask you if x minus 1 into x cubed minus 2x plus 1, something like that. Now, this is missing the x squared. You see that that's missing. It's not there.
Yeah.
So you're supposed to know to rewrite this as 1x cubed plus 0x squared minus 2x plus 1. Okay, so what goes in the box now?
-1.
It's whatever makes this, yeah,
1.
+1. And that's easy to get, off. And then you grab these coefficients here. You should get 0 at the end here. So why don't you give this a try, please? you get one times one is one, add them together, 1 times 1 is 1, -1 times 1 is -1, and it does, in fact. Okay. So it doesn't always work, right? Like you could get ones that do or don't work. There's no guarantee for that. All right, so let's try one last one here. Put 5 in the box. I don't know if this works or not, so just go with it as far as you can.
Yeah. It comes out to 0.
Yeah, that's what it looked like to me, kind of looking at it real quick. And so that means that x minus 5 is a factor. And then this ends up being 2x squared minus x plus 4. And then maybe this factors, maybe it doesn't, but that's for another day and time. So, all right, we're going to stop there for